All right, so boys and girls, for this last very short video, we're going to talk about how matter can change states. The same kind of matter can change states. And a perfect example is to look at water. So by adding or taking away heat, we are able to see difference in states of matter. And maybe you can already tell just by looking at the particles here, which one's a solid, which one's a gas, and which one's a liquid. Yes, this first one is a solid. Ice is water in its solid state. The particles in ice are arranged in a tight, evenly spaced pattern. The particles still vibrate. As ice warms, so this is the second one where we're seeing it's a liquid. As ice warms, it melts into a liquid, water. As the particles warm up, they move and slide around one another. The even spaces between the particles become different size spaces. So that is what allows it to take the shape of its container. And this last one, where the particles are moving around freely and separated from each other, that's the gas. As the water is heated in the teapot, the particles move faster and faster. The liquid boils and becomes a gas. They bounce off one another and fly out of the spout, but they are invisible. As this water vapor cools, it condenses back into tiny drops of water called steam. So let's look at this little diagram here. In heat with heat, if we are to add heat, and we start with ice, if it is heated, it changes to water, or the liquid form. This change is called melting. If water then, so we're in the middle state here, liquid is heated, it changes to a water vapor or a gas. This change is called evaporation. If water is cooled, so heat is removed, if water or liquid is cooled, it changes to ice or a solid. This change is called freezing. So if we have water here and there is enough heat removed, it is cold enough, it will freeze and turn to a solid. If water vapor or gas is cooled, it changes to water or a liquid. This is called condensing. So looking up here, if I have that water vapor and it's cooled enough, it turns into water. A really good example of this is maybe on a hot summer day and you bring out a cool glass of water with ice in it, or maybe a glass of lemonade. If you've ever noticed like water building up on the side of your glass, that's actually just the gas in the air cooling down against your glass and forming water. So it's condensing into water. All right, so I'm going to have you watch this video from Study Jams. And this is a video about different kinds of change in matter, from physical and chemical changes.
I love marshmallows.
What? Don't talk with your mouth full, Mia.
Sorry, I said I love marshmallows.
Oh, me too. But you know what I love even more? S'mores. I brought chocolate and graham crackers so we can make some.
Yeah, RJ. Hey, what's up? Something wrong?
These crackers are all broken into pieces. Look.
No worries. It's just a physical change.
What do you mean physical change?
Physical change is just when the size, shape, or state of matter changes. See, the cracker is broken, so its shape is different, but the pieces are still graham crackers. We can use them.
Yeah, I know. It just stinks that they broke. I don't know how it happened.
Well, physical changes like this happen a few different ways. Motion, pressure, or even temperature could have made the crackers break.
I guess I was a little rough with my backpack when they were in there. Maybe I shouldn't have thrown it around.
Probably not. Throwing the crackers around is probably exactly why they're broken now. But as small as the pieces are, they are still graham crackers, and their molecules haven't changed.
Well, there's no way I could change their molecules. How would I do that?
There are ways. When the molecules of matter change, it's called a chemical change. Chemical changes usually can't be reversed like physical changes can. When the molecules change, the matter turns into something totally different, like the logs in our fire.
But the logs are still logs.
They are, but not for long. The extreme heat of the fire is causing a chemical change that turns the logs from wood to ash.
Huh. Yeah, I see some ash at the bottom of the fire. I guess I didn't realize it used to be the logs. How can you tell that it's a chemical change?
There are clues. If gas forms, if light or heat appears when the change takes place, or something changes colors. You know, like when you see a penny that looks green, or rust at the bottom of an old car.
Oh, yeah, I've seen that. So I guess it's good that I didn't drop the box of crackers in the fire, huh?
That would have meant no s'mores for us. If the crackers had been burned, we wouldn't have been able to turn them back into crackers. We probably wouldn't even be able to tell they were crackers to begin with. So really, broken crackers? Not so bad.
And burnt crackers? No good.
You got it.
Okay, I think I understand the difference between a physical and chemical change now. Breaking the crackers was just a physical change because only the form of the crackers was changed. Temperature, pressure, or motion, like me throwing my bag around, can cause physical change. A chemical change changes the molecules in matter, and that can't usually be reversed. A physical change can be reversed most of the time.
Nice job.
I'm just gonna pretend I understood that and say thank you.